Good morning. Welcome to Introductory Algebra, Section 1.1. Today we're going to be covering variables and how to evaluate an expression and all that good stuff. So just our intro into kind of the basics of algebra. So first of all, what is a variable? A variable is a letter that represents a variety of different numbers. Pardon me. A combination of variables and numbers that uses using the operations of addition, subtraction, multiplication, and division, as well as powers or roots, which we'll get to later, is called an algebraic expression. Some examples of algebraic expressions, x plus 6. So that's some number with 6 added to it. 6x. This means 6 multiplied by x, or 6 times x. So 6 times some number. 6 divided by x, or 6 over x. So that's 6 divided by a number. Always top divided by the bottom when we're looking at a fraction. And there's a lot of other examples, but those are some examples of expressions that we're going to be dealing with. An equation, on the other hand, is a statement that two algebraic expressions are equal. So it looks very, very similar to an expression, except for it has an equal sign. And that's an important point. So has an equal sign. Some examples there. X plus 6 equals 10. So in that case, you can actually determine what x is. Pardon me. Or you might have x's on both sides. So you might have 2 times x plus 6 equals 4 times x minus 10. And once again, because you have an equal sign, you can figure out what x is. Over here in the expressions, those x can be anything because there's no statement that it's equal to something. So these over here are expressions, and these are equations. Just remember, equations have an equal sign. So we're going to get to evaluating algebraic expressions, but before we do that, I want to jump down to the order of operations. So once you have a value in place of a variable, which is what we're going to do shortly, you need to follow the order of operations, and that's simply doing the math. So first off, you're going to do operations in parentheses, or just grouping symbols. So those are parentheses. You might see brackets. Any grouping symbols, that's what you're going to do very first, anything inside of those that you can. The next thing you're going to do is exponent. And an exponent, which we'll talk more about later, but an exponent is the small number up to the left. So if I have 2 to the 4th power, what that means is I'm multiplying 2 by itself 4 times. So 2 times 2 times 2 times 2. So if I see something with an exponent, I'm going to deal with that first. Coincidentally, that one, 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. The next thing I'm going to do is multiplication and division, and those are in the same step simply because you do those left to right. So when we read in English, we always go left to right. It's the same thing with multiplication and division. So if I have 10 over 2 times 3, I'm going to divide, and then I'm going to multiply because the division comes first. In this particular case, it doesn't actually matter, but details. One of the exceptions to that is if I have an entire expression, like 2x plus 8 over 4, if I have a value for x, I'm going to do everything on the top, and my very last step is going to be to divide. And we'll get to some examples like that later in the video. Finally, what I'm going to do is, here, make a point there. Do the top first. Then divide. Finally, I'm going to do addition and subtraction. And once again on that, I'm going to go from the left to the right. So whatever comes first in my reading order, that's what I'm going to do first. So now I'm going to jump back up to evaluating algebraic expressions. What that means is I'm given a value for a variable, and I simply substitute that value in. So I substitute that numerical value into the expression, and then I use the order of operations to simply do the math. So one of the important things is if I have 4x, so if I look at my example here, evaluate each expression for the value x equals 5. So I know that x is 5. When I substitute it in, if I do 3 plus 4, and I just put 5, that looks like 45. And that's not what I want to do. What I want is 4 times 5. So whenever I substitute something in, I'm going to put it in parentheses. And that indicates when you have something right next to a set of parentheses, pardon me, that indicates that you are multiplying those two things. So what I'm going to do here, according to my order of operations, I don't have anything inside the parentheses other than a 5. So I can't do operations in the parentheses. There are no exponents. So the first thing I'm going to do is multiplication. 4 times 5 is 20. I'm going to drop down anything I don't use. So 3 plus 20 is 23. And that's my answer. When you're evaluating an expression, most of the time, unless you have variables that you're not given a value for, you're going to have a single number for an answer. You'll notice that B and A look very similar with a 4 and an X and a 3, but this one has parentheses. So what I'm going to do is 4 parentheses, and then there's nothing bunched up against the X, so I'm just going to put in 5 plus 3. Order of operations tells me that I need to add these two things first. 5 plus 3 is 8. Now I'm going to keep that in parentheses because I know I'm going to end up multiplying that by the 4. 4 times 8 is 32, so that's my answer. Something I want you to start to move away from, this is the same as 4 times 8, 4 multiplied by 8. I don't want you to write 4 times 8. The reason for that is that looks like 4x8, and you don't want to confuse the times symbol with an x. So when you multiply, you're either going to, my preference is that you use parentheses, or you can use the dot, the 4 times 8. Difficulty with that one is sometimes it looks like a decimal, so make sure you're absolutely clear with that. But generally speaking, you should get used to using parentheses to indicate multiplication. Let's go ahead and turn your paper over. The next part of today's standard is translating English phrases into algebraic expressions and also from algebraic expressions back to English. So there's some words that you want to look for. If you are adding, so for addition, you might see plus, more than, sum, so the sum of two numbers is when you're adding, or increased by. And that's not everything that you'll see, but those are some common ones. For subtraction, minus, less than, difference or decreased by. And it matters when you're subtracting. When you're adding, you can do that in any order. But when you're subtracting, you need to be careful that you're sure which one is being subtracted. Pardon me. That order makes a difference. Multiplication, we have times. Twice, that means 2 times. So I'm going to put 2x. Product. So the product of two numbers means the answer when they're multiplied. Or multiplied by. It's pretty obvious, but, you know. Whoops. Division. Divide. Fairly clear. Quotient. And I'm actually going to put over, as in, hang on. By that I mean 12 over 6 is the same as 12 divided by 6. You're probably not going to see that in the book, but you'll hear it a lot. If I say 12 over x, that means 12 divided by x. So quotient, ratio, and divided by. Also fairly clear. So the other one is equals, and that's just simply if you see something that's indicating that you have an equation, you might see the word is equals. That's pretty clear. Comes out to is a big one. Is the one that usually indicates the equal sign. And I can't remember anything else at this very moment, so that's about it. So if I look at some of the examples of translating, the sum of a number and 7. When it says a number in that vague way and it doesn't tell you what it is, that's when you're going to use a variable. So you could use A, B, C, all the way to Z, whatever you want to use. Generally speaking, people use X. So the sum of a number, X, and 7. Sum means that we're adding, so X plus 7. Twice a number multiplied by 2. So twice a number indicates the 2 times x, so 2x, and then decreased by 6 means that we are subtracting, so minus 6. 3 more than the quotient of a number and 11. So 3 more, that indicates we are adding, so 3 plus. The quotient indicates that we are dividing. A number, we're going to use x again. So a number divided by 11. So 3 plus x over 11. So a solution to an equation is the value or values of the variable that make the equation a true statement. So on our last two examples here, we are determining if 5 is a solution to those two separate equations. So I'm going to take 5 and substitute it in for x. So I have 6 times 5, bring down the plus 16, equals 46. And then I'm going to do the math on each individual side. So I'm not going to cross that equal sign, but I'm just going to say 6 times 5 is 30, plus 16 equals 46. And I'm just going to keep bringing down everything that I didn't use. 30 plus 16 is 46. It is true that 46 equals 46, so yes, 5 is the solution to this particular equation. Now if I look over here, 2 times z plus 1 equals 5 times z minus 2. I'm going to take that 5 and substitute it in for both z's. So 2 times 5 plus 1 equals 5 times 5 minus 2. And on each separate side, I'm going to evaluate. So I'm going to do those separately, not crossing that equal sign. 5 plus 1 is 6. Drop down the parentheses and the times 2. Here, 5 minus 2 is 3. Drop down the parentheses, drop down the 5. 2 times 6 is 12. 5 times 3 is 15. And now we're left with 12 equals 15, which is not a true statement. So not equal to. So no, 5 is not a solution to that particular equation. And that is it for section 1.1. That covers our standard using and evaluating or creating and evaluating algebraic expressions. And we will continue tomorrow with section 1.2.